Hello everyone, welcome to my video on indefinite integrals. So we've seen up to now how to solve definite integrals by using FTC part 2. So now we're going to take a look at and analyze indefinite integrals. So here the definition is if capital F is an antiderivative of little f, then the integral of f of x dx equals capital F of x plus c. And we call the integral of f of x dx, this term over here, the indefinite integral. So what's important here is to catch the difference between a definite integral and an indefinite integral. So when we talk about definite integrals, notice that the bounds are defined. We usually have an a and a b here. And when you're dealing with a definite integral, let's write it here, definite, the integral from a to b of your function, dx, corresponds to the net area. Okay, so when you're solving definite integrals, you're going to get a number, a value, and that value could be negative. Okay, so you're talking about the area under the curve. Whereas for indefinite integrals, which we're dealing with here, where the bounds are not defined, you get a function, but not necessarily a function, more specifically, a class of functions, because we have this plus c. Don't forget the plus c. Whenever you're integrating indefinite integrals, you get your answer, the function, plus the constant. Okay, so don't forget the plus c. This is common for students to forget. Okay, so just keep this in mind. Definite integrals, you get a value. Indefinite integrals, you get a class of functions. Okay, let's take a look at a couple of examples. So before we look at a couple of examples, here I'm providing you with a table of indefinite integrals. So here, this is 14 very typical integrals that you have to have memorized. So pause the video, make sure you have these written down, make sure you have these memorized, and we're going to use these to solve the next couple of examples. Notice on the top right, there's an equation that's boxed in red, where we're essentially using the power rule for integration. And this one here is very commonly used, so make sure you have this memorized. So in our first example over here, it says to evaluate the following indefinite integral, and they give us the integral of x to the negative 1 plus x, all that squared, divided by x cubed. And we're integrating with respect to x. So pause the video, give this a shot, see if you're able to solve it with the formulas that were provided. So the first thing to catch is we don't know how to deal with a binomial squared, and which is essentially a multiplication or a division. So what we have to do is expand and deal with each term individually. So let's go ahead and do that. So let's expand the numerator. So x to the negative 1 plus x squared, we could think of it as x to the negative 1 plus x times itself. And now we FOIL. So x to the negative 1 times x to the negative 1, same base, we add the exponents, giving us x to the negative 2. X to the negative 1 times x, so we add the exponents, negative 1 plus 1 is 0, so it's just x to the 0, which is 1. So that gives us 1, and then the middle term here gives us 1 as well. And then lastly, x times x is x squared. All this divided by x cubed dx. Okay, and now we deal with each term individually. So we have the integral of x to the negative 2 over x cubed dx plus, I'm going to add the two ones, giving us 1 plus 1, which is 2 over x cubed dx. Remember, every time we have an integral symbol, it goes with a dx. So this is a package that's always written. So whenever you're writing the integral sign, don't forget to include the dx. And then lastly, we have x squared over x cubed. Oops. With the integral sign. dx. Okay. And now we simplify. So this over here is really just the integral of negative 2. Since you're dividing the same base, you subtract the exponents. Negative 2 from 3 is negative 5. We have x to the negative 5 dx plus, here we could rewrite this because we want it in the form of power rule. Well, first of all, we could we could remove the 2 because it's a constant, and we could treat 1 over x cubed as x to the negative 3, because to apply power rule, as we did with derivatives for integration, we want it in the form x to the exponent n. So working with negative exponents is required in this form. And same here, x squared divided by x cubed, we subtract the exponents, giving us the integral of 1 over x. Okay, this one here I'm going to leave it as 1 over x because it should remind us of something. Okay, so here we have power rule, so we add 1 to the exponent, and then divide by that value. Negative 5 plus 1, be careful, it's negative 4. So we get x to the negative 4 over negative 4. Okay. Since we're integrating an indefinite integral, there's no bounds, we get a plus c that comes out. Okay. But in this integral here, we're going to get a plus c as well. And then in this integral here, we're gonna get another plus c. What we're going to do is combine all those constants and call it one big plus constant at the end. So I'm not going to write it here. I'm just going to write it at the end. Okay, so I'm going to leave it like this for now. Plus 2 times, here we add 1 to the exponent, divide by that value, giving us x to the negative 2. Negative 3 plus 1 is negative 2, divided by negative 2. And then lastly, the integral of 1 over x. You have to remember, if you're applying power rule, x to the negative 1, you would get x to the 0 divided by 0, causing us to have a division by 0, which is wrong. So whenever you see this, whenever you get to the point where you have x 0 divided by 0, you know you made a mistake because you cannot divide by 0. So you have to remember this is in fact just ln. The integral of 1 over x, or x to the negative 1, is just simply ln of x. Okay, and now we're combining all the constants from each term, giving us plus c. Okay, so this is the answer. We're just going to express our answer without any negative exponents. So let's simplify this a bit better. I'm just going to do it up here. Give myself a bit more room. So the answer is, in fact, here we're going to drop the negative 4, giving us negative 1 over 4x to the 4. So we're dropping the x to the negative 4. Here the 2's cancel, leaving us with a negative, and we're going to drop the x squared, giving us negative 1 over x squared. And this is just plus ln of x. Plus our constant, because it's an indefinite integral. And this is the final answer. Okay, so this is the class of functions, and we're done. Let's take a look at the next example. So in this next example, evaluate the following indefinite integral, and the indefinite integral that they give us is x squared plus 1 plus x squared plus 1, all that to the negative 1, integrating with respect to x dx. So pause the video, give this a shot, see if you're able to solve it. There's different ways of doing this. The first thing I see is to simplify what's in the bracket. We have x squared plus 1 to the negative 1. What are they really giving us? This is really just the integral of x squared. Let's separate it actually at the same time. I'm going to deal with the x squared on its own, plus I'll deal with the constant, the 1 on its own, and I'm going to deal with the x squared plus 1 to the negative 1 on its own. Okay. But at the same time, I'm just going to drop, because I don't want to work with negative exponents, I'm going to rewrite it so that we have 1 over x squared plus 1, right? Because we have a negative exponent, it tells us to drop whatever's in the bracket. So we're left with 1 on top, and we're left with x squared plus 1 on the denominator. So now we have these 3 integrals to deal with. So the first one's easy. It's power rule. So we add 1 to the exponent, divide by that value. So adding 1 to 2 gives us 3, and we divide by whatever value we have in the exponent, which is in this case 3. Remember, it's an indefinite integral, so we get a plus c here, but I'm not going to write it at this point. I'm just going to combine all of them together, combine the constants, and just call it one big c at the end. So next I'm going to move on to this one here. We have the integral of a constant. We know the integral of a constant. We essentially just add an x to it. So that gives us just x. It's 1x, right? Or another way you could think of this is 1 is really just x to the 0, and you're applying power rule to this. So you add 1 to the exponent, so 0 plus 1 is 1, dividing by 1 is 1, giving us just x, right? So that's another way you could think of it. And then lastly, we have the integral of 1 over x squared plus 1 dx. This one is probably the most difficult one, so if you got it, good job. This is arctan of x. Or if you wrote it as tan inverse, that's correct as well. Okay. So this one here gives us arctan, that you just have to have it memorized, and plus c. Okay, so if you got this as your answer, great job, because we're done. This is correct. Let's move on to the next example. So the next example, we have to evaluate the following indefinite integral. The integral of 2x to the 1/3 minus 1 over x all that squared plus e to the x dx. So pause the video, give this a shot, see if you're able to get the answer. The first thing I'm thinking of doing is separating and taking the integral of each term. Let's go ahead and do that. And at the same time, what I'm going to do is the first term over here, notice it has the constant 2. I'm going to factor that out. So I'm going to rewrite this as 2 integral of x to the 1/3 dx. That's the first term. The next term, I'm going to write it as minus. I'm putting the minus on the outside. Integral. And 1 over x squared is simply just 1 over x squared. right? If you take the 2 and distribute it to the exponent of the 1 and the x, you're going to get 1 squared, which is 1, and x squared. Okay, so this is laws of exponents. So we get 1 over x squared dx. And lastly, we have the integral of e to the x dx. Okay, so again, remember, every time you have an integral sign, it's packaged with a dx. Okay. Writing an integral without a dx is incorrect, so be careful with that. Make sure you have the correct notation. So let's go ahead and apply the power rule on the first one. So we have 2x, we add 1 to 1/3. So if you have to do this on the side, plus 1 is equal to 1/3 plus 3 over 3. You could think of 1 as 3 over 3, or you could find the common denominator. 1 over 1, multiply the top and bottom by 3. This gives us 4/3. So we have 4/3 in the numerator, 4/3 in the exponent, and then we divide by the same value. So we're dividing by 4/3. Again, since we integrated this, we have to add plus c. It's an indefinite integral, but I'm going to combine all of them together at the end. So I'm not going to write it. Here we have a minus, and here it's not of the correct form. We have to think of 1 over x squared as x to the -2. Right, so we're bringing it up. And now we can use power rule. So we add 1 to the exponent, x -2 plus 1 is -1, and divide by that value. Again, we get a plus c, but I'm just going to combine it at the end. And lastly, we have the integral of e to the x. So this one we know, e to the x remains the same, plus c. And this is the answer. We just have to simplify. We cannot leave our answer in this form. We don't want the fraction on the bottom. We don't want negative exponents. Let's get rid of that. This is, we're dividing by 4/3. So whenever you have a fraction divided by a fraction, you multiply by the reciprocal. So you're going to flip the 4 over 3 and multiply it with 3 over 4. So we have the 2 in the front on top times, instead of 4 over 3, it becomes 3 divided by 4. We're multiplying x to the 4/3. Here the two negatives cancel, and we're going to drop the x at the same time, giving us plus 1 over x plus e to the x plus c. Last step here, we could simplify. 2 times 3 is 6 divided by 4. We could reduce that to 3 over 2. So we have 3x to the 4/3 over 2 plus 1 over x plus e to the x plus c. And this is the final answer. This is the indefinite integral. Okay. So let's look at the next example. So in the following example, we have to evaluate the following indefinite integral, and we have the integral of cos theta times cosecant squared of theta d theta. So up until now, we've been integrating with respect to x using the parameter x, but here we have theta. So at the end of the day, the letter that we're using or the parameter that we're using doesn't matter. You can use any letter you want. It's customary to use theta when dealing with angles and trig functions. So in this case here, we have theta. If you're solving a physics problem, you might be integrating with respect to the parameter t, so it doesn't really matter. Don't get attached to the letters, okay? So let's go ahead and solve this problem. Again, we have another issue. We're multiplying. How do we deal with multiplications? At this stage, we don't have any tricks for multiplication, so our only technique that we have at this stage is to rearrange this. Switch cos and cosecant squared using your trig formulas from secondary 5. So let's go ahead and do that. We have cos theta, and I'm going to rewrite cosecant squared theta as 1 over sine squared theta. Because we know that sine theta is equal to 1 over cosecant theta. Okay, so they're reciprocals of one another. So if you square both sides, then that means cosecant squared is equal to 1 over sine squared using cross multiplication. So I'm going to multiply the cosecant squared on the left and right side, and I'm going to divide by sine squared on both sides. So it's essentially cross multiplication. So cosecant squared is rewritten as 1 over sine squared. This is the property that we're applying here. Okay, but we're still stuck. This doesn't really help us because we still have a multiplication. Or if you put the cos on top, you have a division, which we don't know how to deal with. If you've learned u substitution, you could actually apply a u substitution at this case to solve the problem. It's going to work if you use u as sine, but we don't know u substitution yet, so let's avoid that method. So here what we could do is think of cos theta over 1, and let's split up the sine. So we have cos theta on the bottom. I'm going to take one of the sines from here and write it as cos theta over sine theta times 1 over sine theta d theta. Okay, so we're dealing with this term and this term. It's not separated by an addition, so there's no two integral signs, it's just simply one because it's a multiplication. And we could rewrite cos theta over sine theta as cotangent of theta, right? We know sine over cos is equal to tan, so cos over sine, the inverse or the reciprocal, is equal to the reciprocal of tan, which is cotangent. And 1 over sine is equal to cosecant from the property that was expressed earlier. So we have cotangent times cosecant, and this should look familiar. What's the integral of cotangent times cosecant? Well, the answer is just negative cosecant theta plus c. Because it's indefinite, we have our plus c, and we know that the derivative of cosecant is cotangent times cosecant, and we have to add the negative because it starts with a c. We saw this in our earlier videos, and this is the final answer. So make sure you have your basic integral formulas memorized, and this allowed us to solve it this way. Not the only way, we're going to see different ways to solve these problems later on, but for now this is the final answer. So let's move on to the last and most difficult example. So in our last example here, it says to evaluate the following indefinite integral, and the integral that's given is the integral of secant x times, in brackets, secant x plus tan x dx. So we're integrating with respect to x. Pause the video, give this a shot, see if you're able to solve it. So at this point here, again, we have a multiplication which we don't know how to deal with, and it's difficult if you don't see the trick, but the trick is simply just distribute the secant x. Once you do that, that's the key to this problem, and you made it simpler. So secant x times secant x is secant squared of x dx, and I'm going to separate it at the same time. So that was the first term, and the second term is secant times tan. So plus secant x tan x. Since it's separated by an addition, I'm taking the integral of both terms individually. So integral dx, make sure your notation is correct. And now we're integrating secant squared and we're integrating secant tan. So what's the integral of secant squared? From our basic formulas, we know this is tan x plus c, but again, I'm going to combine it with this constant, so I'm not going to write it just yet. And the integral of secant tan is simply secant. Okay. Since they both have constants, we're going to combine them to put plus c over here. So don't forget your plus c, and this is the final answer. So I hope this video helped. I hope you have a better understanding of indefinite integrals, and I'll see you in the next video. Keep practicing.